Okay, thank you, Jens, for introduction. I won't repeat it, so let's start right away. I'll introduce Dataplex Lineage as our product. Talk about how we support OpenLineage, how the integration went on the way, and what improvements we would like to propose to make. To make it go smoother, like for the future us or for similar integrations. And we will have time for the questions in the end, but if something is unclear in the middle, I'll also watch for raised hands in between the sections. So here I have a formal definition from our documentation, but basically data lineage is a Dataplex solution for tracking and visualizing data movements, also known as lineage. And when you work with it from GCP, you mostly see similar graphs, maybe more complex. So here I loaded a dataset from BigQuery to my project, and then ran two pipelines on it, one in BigQuery, one in Dataproc, and saved the result to BigQuery. So, for example, if you notice that something in the last table doesn't look the way you expect, you can trace it back and see, oh, there are actually two processes writing to it. So maybe they overwrite each other. You can see what data they're reading from, whether it is correct, and how it was loaded. And the same downstream. If you want to know how your data is used, you can you can see what is down the road. So for GCP products, we have native integrations. BigQuery, the Cloud Data Fusion, Cloud Composer, and Dataproc, which means you just need to enable Lineage API in your project, and it will be reported automatically. And for a custom integration, it should be reported via our API. So I'm going to briefly describe it. So how do we represent Lineage internally? For each definition of a data transformation process, typically a script, we have a process. And then each execution of this process is called a run. And within the run, there are concrete data transformations and their state. And those are called events, which contain links between sources and targets, so between data assets. And as an example, for Dataproc Spark, we have a job definition as a process. Then each execution of this process would be a run. And within this run, we have data transformations represented as events, and they contain links. So if you work with the graph, you see two tables, a link between them. And when you click it, you see what process produced these links, and the runs of this process, so the executions. Now, how does it work under the hood? So if you plan to integrate with data lineage without using OpenLineage format, you would have to define the mapping between your notion of data processing, so process, run, etc., to our data model, and then do all the transformations and wrap it within RPC call and report it. So that means that this whole integration is tightly coupled with GCP because you would basically transform the information to our format. Now, with OpenLineage, it's a very similar picture, but instead of customer connectors here, we have OpenLineage connectors. So, for example, for Spark, you would install Spark listeners dependency, and this whole work of creating the message, emitting it, would be basically reusable. So you would get more flexibility between Lineage consumers, hopefully towards Dataplex. And that is the way to integrate that was piloted by Dataproc. So Dataproc Spark, sorry, so they would report via OpenLineage. Now, what are we doing with OpenLineage messages on our side? For each job, we have a process, and job facets are represented as process attributes. And the same for the run. And then run event loosely maps to lineage event. And for inputs and outputs, we are creating a Cartesian product of those and create links. So I'll move to the challenges if there are no questions.
Do you accept OpenLineage events from like arbitrary connections targets? Is it an open API, or do you accept only from Spark?
It is an open API, but to see it on the UI, you would have to have the assets in Dataplex.
Okay, so I can't like just run OpenLineage thing integration right now and have them. Okay.
But you would still be able to fetch it the same way via API, just not. Yes, sorry.
I've got other question. I'm Kuba. I work for Allegro, and we use OpenLineage for Spark running on Dataplex already. And I was wondering if you are able to change the consumer of OpenLineage events generated by the default data lineage API. Because it is great that you can right now enable the data lineage API and simply generate the OpenLineage events. But we'd like to change the consumer of it to our, let's say, custom service on Cloud Run, for example. Is it possible? Do you know?
I can return to you after the presentation. I don't know.
Maybe very spot there. So you want to commit Spark OpenLineage events into Dataplex, for example, right? And you're asking whether that's possible.
No,
emit them from the Spark job on a Dataplex,
yes,
but consume them on
somewhere else.
Somewhere else.
Right. All right. Okay. Yes. Well, I think we need to check whether that's possible because you need to fiddle over a bit with the configuration of Dataplex.
Okay, I got it. And my question was because we add some additional URL params with metadata of the job, and we consume them later. And that's why we use custom service to consume those events. And that's all the need at the moment. So okay.
Okay. Well, thanks a lot for the input. So I'll move to the challenges that we faced during development, and as we mostly explored Spark, they will be related to Spark. So the first was rather an ambiguity than a huge challenge. But when we were defining the API endpoint, we had to basically listen to two sources of guidelines. One is Google-owned API improvement proposals, and the second one is OpenLineage format itself. So in most cases, it was straightforward what to follow. But when we were defining whether to process messages synchronously or asynchronously, there was a small conflict. So the AIP stated that if a method takes significant amount of time to complete, it should be asynchronous. At the same time, we saw that OpenLineage client already developed synchronous. And after giving it a thought, we decided to go with synchronous mode, but also limited the message size to make sure we can kind of predict the time of the request completing.
Sure, okay. We can send events to Kafka, and I want to be able to configure Kafka in a way so that it's asynchronous, that we don't wait for.
I think this a field for greater discussion.
Yeah.
Because there are some things that make this possible to make it asynchronous, but then Spark can like complete before you send this event or before you get positive answers.
Okay.
Good, thank you. So another one is versioning of the OpenLineage format definition. So we needed to be really confident about what we can support and also communicate it very clearly. And on one hand, we needed to be flexible enough not to block users each time OpenLineage upgrades. But on the other hand, we needed to be strict enough to reject the messages we are unable to handle. And we ended up with an assumption that there will be no breaking changes between major versions, and defined a flexible enough API. So if, for example, a new field is introduced, but it's optional, we still don't know how to read it, but also we don't reject the message completely. And as a result, we support OpenLineage 1, major version 1. The next one is the updates per run. So in our mental model, we expected the process, one execution of the process to produce one run. And then we observed that Spark just emits new run events as it executes. And as a result, there was a mismatch between our architecture and the actual input we received. But then we noticed that most of the runs we received don't add incremental information to the run itself, only events. So only, sorry, inputs and outputs. So we still create them every time, but we don't alter the run if nothing actually changed about it. So I'm saying it's mitigated, because while we do not overload the database anymore, we still do all the heavy lifting for sending requests, then receiving it, parsing it, processing, etc. And as a result, there is no incremental value of doing all this work. So maybe if it was batched logically and it was some actual information that those run events belong to some execution stage, we could take more advantage of it. There is also one challenge that we still have to tackle. So we know that formally inputs and outputs are incremental, and we can receive them between run events. For example, we have two messages. In the first one, inputs are together with output. So we take the partition product and link them correctly. And for the second one, with the current implementation, we would not be able to find the connection between them. So basically, this data is not injected as a result. And that's all for now for challenges. And we also, there are also two proposals that are already submitted to OpenLineage GitHub, but we will give them more visibility now. And they are both related to column level lineage, or to be precise, to the facet that describes a particular transformation. So the first one, now this data transformation facet is defined with a transformation type that is a string with two expected values. And for some applications, it would make sense to formalize it and introduce different types of masked, basically. And also a subtype to give more precise information. Why it can be important? Let's imagine we have one process that groups by a sensitive data asset, and another one then hashes it. Now, the first one is indirect usage of the data, so for many reasons it can be treated as safe. And the second one, well, we need to know whether hash is, like, whether we can reverse it, whether we can somehow use it, so it can warrant investigation if this information is really sensitive. So it would bring more value to distinguish those two cases. The second proposal is also about this transformation type. So now it's defined for all inputs and output for the whole operation. But again, it would make sense to have more granularity and define it separately for each input. why it can be important. Again, imagine a process that takes some arbitrary input and PII, and then it copies arbitrary input and groups by PII. So again, we can say for some applications it's safe. The second one does vice versa, groups by some arbitrary input and copies PII. Now that is definitely PII leak. So if we then aggregate it and put the same transformation types on it, we basically equalize those two situations, while in reality they can be very different and have different impact. And that's all I have for proposals today and for the presentation. So yeah, we've talked about Dataplex lineage, how it works under the hood, and what challenges we faced. And if you have any questions,
Question. Are you also capturing the status of the process run or just lineage, right?
We do.
So you don't like in lineage, you can show what is the current status of the
Yes, we captured it when it started, intermediate, and finished.
So maybe I can add something to the point about those incremental events. And there are, I think, two cases for first to have a lot of events for maybe one run, right? And those are streaming data sets, streaming jobs, which we are going to tackle better, I think, soon for Flink and for Spark streaming maybe. So then you can have running events that, for example, can tell you what's the actual status of the job, or maybe what's the progress, or like in Flink, what's the current checkpoint. Basically, if you have a long-running job, then get start event, and then nothing, then like you may wonder, is it really running if it has been 36 hours, right?
Right.
So we have some ideas around that. And regarding those different data sets and different events, sometimes we can know everything about this at start, right? Let's say we are talking about Spark job, and then we have a logical plan that explains we're reading from this source, writing to this source, and it's great. But then I think Jakub will have, we'll talk about this more. We can have arbitrary code that maybe is instrumentally assigned, right? But until we run it, we don't know whether it will like send output anywhere, right? It can run, it can have input data sets, output data sets, but we don't know. So in this case, we just have to execute the code, send additional information that we may get later.
Okay, yeah, I see
That's
how
the
it's
idea behind this different events and incremental updating state.
Yeah, I see how it can be challenging for working also. Thank you for the comment.
So it's interesting that it works like this for the current implementation. But when you look at the column lineage facet, then there you expect currently inputs and outputs to be received at the same time, right?
But do those two run events on the right share the same run ID?
Yeah. I think it's just a mismatch from like different mental model on our side and what currently OpenLineage does, and we will need to follow that. But
I would like to see this case actually, because this is a great action.
Isn't it just assumption on our side that the events are cumulative and pick all the data sets from all the events you have to get the overview?
I think our assumption is that we want to know exactly which data sets were inputs to which other data sets. So that's why we have this mental model of a link as the atomic unit. But in this case, when we receive events, let's say for a specific run, we receive multiple events with different input outputs. We don't know which input exactly was actually feeding into which output, right? Which is at this, let's say, table level lineage. That's the case in OpenLineage. But for column level, the facet actually makes the assumption that there actually defines the links, right, between input columns and output columns directly and atomically.
In Spark is easy because there's only one output, right? There's only one output node. But for other integrations, you can have multiple outputs, and then
Yeah.
and,
Exactly. Yeah.
So I remember when this assumption came from. So for the storages like Iceberg or Delta, we are able to capture the version of the data set. And there's a kernel case that you can read from the same data set you're writing. And in this case, it makes sense to capture the version of the input data set at the start and of the output data set at the end. And I think that would lead us to this place here, which becomes problem.
You had some comments, Maciek, before about what was the other. The other one?
Synchronous, yes.
Yeah. So
Sorry, I'll just find
for
that.
Spark,
Uh-huh.
we are running in like this Spark event loop, right? Our integration runs like that, and it can. We basically are sending some message right somewhere, but we are not sure if we are not being killed, right? Because we are sending something, we don't get an answer. Maybe you're processing message 15 minutes. Who knows what happens, right? Or the message size. If you enable some debug facets, the messages can get really huge. I think we had a case where we serialized the logical one, right, as a debug, and it had like 22 megabytes, and tried to send this to something that tries to parse it, and it can be a problem, right? So we have a concept of transport in OpenLineage client that allows us to specify how exactly we should send the message somewhere, right? And if you like use gRPC in Google, then you can add gRPC transport and then do whatever you want. You'll just get called, right, with some init method. You can process it in the background, right? But this way you won't get any confirmation that it has been delivered. And I think if we are working with metadata, it's important to know. But yeah, I think if we want to improve on that, we kind of need some native integration with like Spark, something like we have in Airflow, that maybe guarantees us that like we won't get killed during sending the message. So in general, it's a hard problem. Doing this synchronously gives us some at least guarantee.
Okay, that's interesting.
Are there other
Other
questions?
questions?
We see a potential issue on this topic with synchronous systems. I understand correctly, OpenLineage operates only in synchronous mode, right?
Kinda, I would say. You can use asynchronous. You can write your own transport and send events asynchronously. But you won't get like a feature that you can wait later on in the process, right? So it's just fire and forget.
If I understand correctly, this synchronous mode is where the client sends a request and receives a response whether the request is successful or not.
Yes.
Versus asynchronous client sends a request, receives something here, and can check the
Yes,
status.
that's
And this puts us a theoretical limit on the basically size of messages of each can process. And we need maybe a different model. Like asynchronous model offers some workaround for the size limitation. Synchronous model doesn't. I see a theoretical issue here that cannot easily be overcome. Like any system can fail. You cannot change the picture and say that our system will never fail.
yeah, I agree that we can send too large of a message that way. In practice, this happened only if you turn on some debug events that basically, I don't know, serialize practically the whole state of like Spark session. And we think that the metadata, right, shouldn't be as large as your data, maybe. I agree that we should probably do some more work on more reliable delivery. But I think this is still like issue that warrants bigger discussion and maybe something that needs to be tighter coupled to the actual system we're integrating with. Because like I said, like Spark event listener doesn't give us a way to like reliably work in every case, right? In case that you have short-lived like Spark job, can get killed and you won't know.
Yeah.
Maybe ask questions. Are there any questions on the from the audience on the call? Were you actually able to follow the discussion over here? Michael? Oh, mostly okay.
Okay.
I think we should operationalize this microphone.
Yeah.
Okay, we will use the microphone from now on. That was a miss on our side. Yeah, we'll improve on that. But are there any questions from your end at the moment?
Okay, if there are none, then thank you very much.